It's Saturday and I do not have the patience. Just got done fixing a beer walk-in, got it up and running. This is all that my van's gonna get right now. I'll clean it another day. It is what it is, right?
This video is brought to you by Sportland. Quality, integrity, and tradition.
Well, it's a Saturday afternoon. We got a service call on a beer walk-in that's too high in temperature. So it's set for 35 degrees, but it's 52 in here. So we're definitely gonna have to get up on the roof and figure out what's going on. I don't see any ice or anything on the coils, so. So we have our refrigeration rack right here. This is a common rack. Several condensing units in it. This right here is my beer walk-in compressor. It is not running. There is overheating on the top of the compressor shell. Tell where the paint's peeled off. That's not good. The compressor itself is not hot at all. Yeah, it's not hot at all. Looks like maybe we have a refrigerant leak right here. Something. Other compressors are running. So let's go over here to my electrical panel. We open this up. Doesn't look like the breakers are tripped. Our time clock is going to be system C right here. This is our time clock. It's in refrigeration mode. Kind of hard for you guys to tell. System C breakers are not tripped. System C contactors are up here. So we're gonna need to start, I would say, because understanding the system operation, we're gonna start at the low pressure control, which on this one right here is a dual pressure control. So we're gonna open that up and check to see if we're maybe open on low pressure. Judging by the signs of refrigerant oil, I bet you we are. This is a standard dual pressure control. It has one set of electrical contacts across it. So those two wires right there control the low pressure side and the high pressure side. So if we simply put our meter on volts AC and check across, and we get 200 volts, this guy is open right now. So I think we are out of refrigerant. I think we have a massive catastrophic refrigerant leak somewhere in here, and we're gonna need to figure out where. Whenever using digital gauges, whether it be a manifold or probes, you always wanna make sure that they're zeroed out before you apply pressure to them. I'm turning off the wireless because I don't need it to kill my battery. So before you apply pressure, you wanna make sure they're zeroed out, that way you don't get false readings when you do apply pressure. So we're gonna open up the high side, very, very low pressure in the high side. And we're gonna open up the low side. Very, very low pressure. So my system is pretty much out of refrigerant from the looks of it. So I did bring up a leak detector and some soap bubbles. So we're gonna try to identify this refrigerant leak. It looks like it's gonna be somewhere in this area right here. There's clearly just oil everywhere right there. It's gonna be a little difficult to see, but right here is a refrigerant leak right on the pressure control stem. So we're probably gonna luck out here because our system barely has any refrigerant in it. I'm gonna be able to change this on the fly is the plan here, because we never ran out of refrigerant completely. So I can bust this off real quick under really low pressure and put a new pressure control on there, basically do a hot swap. Yeah, and then we'll be able to determine whether or not there's more leaks. I'm just gonna get myself through a Saturday as the hopes, and then maybe we can come back next week and clean it up a little bit. We'll have to see. But yeah, let me go down and make sure I have a dual pressure control, which I'm pretty sure I do. And then we'll see what we can do. Because this system never completely ran out of refrigerant, I'm not gonna have to pull an evacuation, and I'm not gonna have to change the liquid line filter dryer. What I'm gonna do is get everything set up, get the new control installed, leave this one kind of pushed to the side. and quickly do the low pressure with it having that small amount of pressure in it. It'll be really easy to change it, and do the same thing for the high side pressure too. Really quick, the system will never run out of gas, and it'll save us having to do a full evacuation. But I will say, judging by the top of that compressor, that paint's all cracking and crinkling in there. That's not a good sign. But that also could be because it was running low on refrigerant for a while too. It's hard to say. So, all right, I'm gonna do this real quick. I already turned off power. It shouldn't be a hard swap at all. All right, we're about halfway there. Pressure control in electrically, coiled up right here. I pulled off these existing lines and just put caps on them. It barely has any pressure, so we're fine. And then we're gonna connect that back. We'll put some nylon on and tighten it up. Now, 404A is a blended refrigerant. First off, it's a near azeotropic blend, right? It's very minimal, the glide on it. So I'm not really worried about it fractionating, right? But at the same time, even if it was going to, there's so little refrigerant left in this system that I'm about to dump. You know, I imagine there might be 2 pounds of gas left in here, if that. Maybe a pound, if that. And I'm about to dump, I think, like 21 pounds of new refrigerant on top of it. It's not even gonna make a blip, okay? But this is just saving me from having to do an evacuation. This is an emergency repair because their beer walk-in's at 50 degrees. They're not selling beer. We need this fixed ASAP. Now, I may decide to come in later and change the dryer, who knows? But right now, we're just worried about getting this thing up and running. Now, if it ran out of refrigerant completely, then yes, I would have to pull an evacuation. I don't care how much of a hurry we're in, but it didn't, so we're good to go. So I'm gonna put these other guys on, put some nylon on them, get it up and running, and then we'll charge the system up and go from there. All right, I weighed this down at my truck. I actually know that I don't have enough refrigerant. I'm gonna have to go get some, but I'm at least gonna get it up and running. The amount of refrigerant that I don't have is going to be the winter charge. So I am going to have to go get some today because we are supposed to get rain tomorrow and the temperatures will drop. So we want to make sure that for the head pressure control valve that we have enough extra refrigerant. But for now, I'm going to get them up and running. So controls installed, leak free, everything's good. I'll secure it with silicone and stuff later. I've purged this guy. I've opened up my process port. We're going to dump it into the high side as much as it'll take. Right there, a little leak right there, but that's okay. Dump as much into the high side as possible. We're gonna let it take that whole thing because I know there's not enough refrigerant there. The total charge on this guy is 19 pounds. And I bet you, I weighed it down to the van, but I think that this cylinder, I wrote it right here. The cylinder weighed 18 pounds down at the van. These guys usually weigh about 6 pounds empty. So we're clearly not gonna have enough gas, but this will get us up and running. So we're dumping as much into the high side as possible until it won't take it anymore. Then we'll let it stabilize out. Then we'll turn the system on and start metering it in through the low side once we've gotten as much out of the tank, you know, as possible at this point. Now I understand the sequence of operation for this system. So the temperature controller, solenoid valve, and everything gets its power from the time clock. This is an electric defrost cooling system downstairs. So when I turn this on, the solenoid valve's gonna open up and our pressures are gonna rise. There we go, we're rising, and it's gonna turn on here in just a second. There we go, we're on. So now I'm gonna start adding gas to the low side. Again, I know it's gonna take my full tank of gas here because this thing was damn near out of gas. So I'm just gonna keep adding refrigerant, metering it into the low side until it won't take any more. Of course, I'm paying attention to the sight glass over there. It just started flashing. Things to consider when you have refrigerant leaks is how much oil actually leaked out of the system. One thing to understand is a drop of refrigeration oil goes a mile, so sometimes it can look a lot worse than it is. But the nice thing is this compressor has an oil sight glass. Doesn't look too bad. It looks like right about the halfway point. So we're just about done with this refrigerant tank. I've got it opened all the way. It's just vapor. I can't see any liquid in my sight glass right here anymore. And we've just about put all of it in there. We are not even to a clear sight glass yet. It's still flashing. So this will get me operational. I'm gonna have to go and either open up a supply house or go find one of my other service technicians and get a drum of 404 out of his van, because I don't have any more. I'm short right now. So I will be back right now. I'm gonna take down the tools that I'm not gonna use anymore, so that way when I come back, I just have to, you know, put the remaining refrigerant in the system. But this way, it'll start bringing the box down to temperature too. All right, I am back. I went and found some extra refrigerant. I had, one of my employees had some, and then I also had some at the shop. So I got this half full drum for my employee, and then got a full drum for my van from the shop. Now, I need to add 11 pounds of refrigerant to this. So this particular manufacturer has it written down how much this system takes fully charged, accounting for the added refrigerant for the winter charge. So I've already added so much, so I know that I need to add 11 pounds more. The system is coming down in temperature. We'll go down and verify in a few minutes, but we're just gonna add it till we get to 11 pounds. All right, I have added total 11 pounds of refrigerant, including this extra 3 pounds right now. So 8 from the previous drum, 3 from this. My sight glass just cleared right over here. If I can get it to focus. So the sight glass just cleared. This is the proper charge, not accounting for the flooded charge or the winter charge, okay? The extra gas needed for the head pressure control valve to bypass. Now, everything we add is for the flooded charge, okay? So I needed, from this drum, I needed 11 pounds total. So what is that? 10, 9, 8. So 8 more pounds of refrigerant for the flooded charge. It's always good to pay attention to that information. All right, it's nice and cold in here now. The coil's a little frosty, but that's okay. And let's see if we can see the thermostat. Yeah, it's about 35 degrees. I think the set point's like 32 because it's a 33 because it's a beer walk-in. But this will get them through the weekend, and I think I'm gonna come back and change the dryer next week. All right, it has been a couple days and I am back today. We're gonna go ahead and change that dryer and sight glass. I can hardly see the sight glass. It's all covered in calcium from a couple years back. We had a crazy summer where we were hitting a lot of 120 degree weather, and we had to run misters on a lot of equipment. And we've been slowly repairing the equipment, you know, sight glasses and things like that. But we're gonna go ahead and change this guy out. And it's currently turned off, so it's either pumped down or in defrost. So let's go over here. That is not a crack pipe, by the way. I was wondering that too. It's a piece of a pin. System C is not in defrost, so it's probably just satisfied downstairs. We're gonna be working in this side right here. Ow, that hurt. This is my system. We'll be putting a sight glass and dryer right there. I'll put in a flare, so we'll be redoing some repiping and stuff, make it look pretty. When we are applying service gauges to our equipment, I know this often gets forgotten about, and even I'm guilty of it. I forget to do this sometimes. We need to loosen the packing, right? So you get right up in here when it's possible and just loosen on that before you actuate the valve itself. And this one I've already done, but it will save the packing gland. It should be loose. Make sure it's nice and loose. Now understand something, that when you do that, it has the potential of leaking. So keep that in mind. You may have to throw a cap on it, or if it leaks too much, just tighten it down once you've actuated the valve. It will save your service valves from wearing out and from leaking if you do that on a regular basis. So this one started leaking when I did it. But now we have system pressures, but I'm really curious. Oh, okay, I was like, why is the pressure equalized, but my gauges were open? So that's why. And there we go. Now, there we go. We just turned on because unfortunately when I put my gauges on, they were equalized out. So now it should be pumping down by the solenoid valve. We need to pump the entire refrigerant charge into that receiver. So I'm gonna actually have to go close the king valve on the receiver and wait for the system to turn on, and or go downstairs and get it to turn on by raising the temperature. So that way all the refrigerant can be stored in the receiver while I'm making this repair. Not really a huge fan of these, but I see the benefit of it. You have a queen valve and you have a king valve. The king valve shuts the flow coming out of the receiver. The queen valve ruins your compressor. And what I mean by that is if you shut this valve down, it no longer has a tank to go into. But if you shut this valve down, it allows the refrigerant to build up in the tank and be used to pump the system down. So don't ever actuate the queen valves if you don't know what you're doing. Leave that one alone. Now I've already loosened the packing on this one. I made sure that this right here was nice and tight. So we're just gonna go ahead and front seat this valve, and the refrigerant flow is gonna be stopped coming out of the receiver, and it's gonna back up into the storage vessel, and it's gonna shut down the flow to the low side. That way we can perform service on the low side of the system. We're gonna put the cap back on so that way it doesn't leak, and we'll go over and monitor the gauge pressures, and then we'll get in here and start cutting stuff apart. All right, my system is pumped down now, so now I'm just kind of getting ready because I want the system open for the least amount of time as possible. So I already grabbed my tubing benders right here, pre-bent this guy about where it should be, right? And it's long, so that way I can trim it down. I've got some flare nuts right here. Of course, I got Sporlan catch-all dryer and a Sporlan see-all sight glass, and we do flare with the male-female sight glass, so they couple together, just like all the other ones that I've done right there. Okay, makes it really easy for servicing later. All right, so we're gonna put this together, then we gotta trim these down, deburr it, flare it. I got my flaring tool right here, and we'll get this guy set up, and then we are gonna have to do 2 braze joints. Now, because this system is a pump down system, we can't really purge with nitrogen because there's no way to relieve the pressure, and you have the potential of contaminating the system with nitrogen. So it's kind of a tricky thing to do unless you were to add service ports and different things, but it's not gonna be that big of a deal. So I'm just gonna prep it, and then we will have to do the 2 braze joints somewhere right here and somewhere right here. We'll have to do a braze joint, but it shouldn't be a big deal. I've been using this flaring tool for all my career, to be honest with you, and I think it was my dad's before that. It works great. I have been considering getting a new one because it's finally starting to get worn out, but it still does the trick. Doing a flare, in my opinion, the key is carefully deburring the edge, but not deburring it too much. Get a nice clean flare, make sure the pipe is good, it fits in there. Same thing on this one. Nice and good. Make sure you put the nut on before you flare it, and make sure the pipe is straight. But yeah, both of those look good. So I'm gonna go get my swaging tool, and we'll have to swage this in before you use the, I'm using the spin swage, but I mean with any swage, you also wanna make sure that you deburr it. We'll get the swaging tool, my torches, and we'll have to figure out how we're gonna make this work. Got our liquid line filter dryer and the sight glass. We're gonna use a little bit of Nylog right on the surface right here. We'll just put a little bit. Doesn't take much. And then we'll put it on the flare nuts too when we're ready. Another thing is there's an argument to be made. Well, actually, I've made this argument many times. We're gonna be evacuating through our manifold gauge set, and something to understand is the entire time we're doing this, vapor is still boiling out of all the oil throughout the system. So we're not gonna be able to pull a perfect vacuum, but this is also, you can see the refrigerant boiling out of there. It's also not as necessary on a pump down system. Of course, you still need to pull an evacuation, but you're never gonna see perfection because you end up pulling all the refrigerant out of the receiver. All right, put Nylog on everything. Got this all set up where we need to be. Got the low side hose taken off on the other side so that way the pressure has a place to go, because remember, all that refrigerant is still boiling out of the oil. So we just need to braze this one and this one. Everything's already torqued on and looking good. right, so what happened was I brazed this one up, but then I saw like a flame coming out because the pressure wasn't being relieved. And the unit actually went into defrost and the liquid line solenoid valve shut. So I had to go take it out of defrost, and then I was able to braze it up. So we're good to go. We're gonna cool those off, inspect them with the mirror, and then we'll get the evacuation running on this guy. This is what I'm talking about. I haven't even started the vacuum pump, and that's just the refrigerant boiling out of the oil. So we're gonna vent that so we're not pulling a crap ton of refrigerant with the vacuum pump. And then we're just gonna pull a quick vacuum through the gauges. It's not gonna be perfect, but it'll, you know, just get the potential air that we might have gotten in there when we put the dryer on, but that's it. But the entire time we're doing this, that refrigerant is just boiling out of that oil. And on top of that, all the valves in these systems leak. The king valve on the receiver, like they're not 100% leak free. You never know if you have a messed up reed in the compressor. Well, it's not really a reed on these ones, but still, just understand that, you know, it's not going to be a perfect evacuation because we're only pulling on the low side. The high side still has full refrigerant in it. We are running, currently right now the head pressure is building. The head pressure control valve is going to be bypassing, driving the head pressure up. It's probably about 50 degrees outside right now, so. Sight glass is clear, that's a good sign. Some dodo heads, they had someone come in and install new ice machine condensers over here, and they just ran SO cord all the way over. It's driven me nuts for years, but the customer hasn't wanted to fix it because it works. One of these days I'm just gonna get in there and do it because that stupid cord is driving me nuts. But okay, so yeah, we're gonna watch this thing operate for a little while, and then we'll do a leak search around the flare fittings. This guy's done, and I was just kind of wrapping some things up, and I come over here. I didn't even catch this earlier. Look at that feed. Line 1, holy moly. That's bad. I don't know if that's repairable or not. I'm gonna get over here and cut the wire back because it looks like there's some extra, and see if we can salvage it. If not, we're gonna have to get a new breaker. I don't know, this is interesting. All right, I have power turned off and isolated. If you come right here, as I suspected, it's loose. So I have to open it up and inspect it. The other ones are tight. Yeah, the other ones are nice and tight. That one was loose, so I need to inspect the inside of the breaker. It doesn't look like it's damaged, but you gotta watch out. But I think I have enough wire to pull it back and cut it back, hopefully. It's not ideal. I mean, I'm not in love with the fact that the wire is coming up here, but I had to cut off a lot. I basically felt where it was rigid, and it felt rigid all the way back to here, so I cut it off right there. So the wires are not burnt right there. And then I torqued down on this really, really good. Unfortunately, I don't have an actual torque tool, but I think it's tight enough. I'll bring it up to the customer's attention. If they want to permanently fix this, I mean, I guess we can do splicing lugs in a perfect world. Yeah, I'd hate to have splicing lugs in here, but sometimes you got to do what you got to do. But I'll bring it to their attention, see if they want to go any further with this. We'll keep an eye on this breaker. I'm going to turn it back on, check voltage and everything, make sure it's all good. But I think we caught a problem before it ruined some compressors, hopefully. I am not a perfect technician. I am lazy. I don't want to do any more work than I want to. You know, I'm not perfect, okay? In this situation, I took a shortcut. And while there's not, I don't think, going to be any problems from the shortcut, it happens. We have to understand, though, that when we take shortcuts, there could potentially be repercussions because of that, okay? Understanding the sequence of operation of our systems, understanding what happens when refrigerant fractionates, okay? When refrigerant fractionates, we're talking about the different boiling points of the refrigerant, and the refrigerant itself you know, is a multi-component refrigerant. There's multiple refrigerants in there making up R404A. And when it fractionates, you could potentially let out one type of refrigerant. And then you only have two components left, or however many different refrigerants there is in there. So you could then theoretically make a new refrigerant that wouldn't act and respond to temperature the way that 404A does, right?
Now, in this situation, I don't think I'm going to run into any problems, and I'm willing to take that gamble, but we need to understand the repercussions if it did fractionate and it made a new refrigerant, and then it doesn't, react the way that it should to the temperature pressure chart. Think about a thermostatic expansion valve that opens and closes depending on the line temperature, the suction line temperature, right? And the pressure on the liquid line coming into the expansion valve. It's set up for a particular type of refrigerant. And if you change that type of refrigerant and continue to use that same thermostatic expansion valve, then theoretically it could not feed properly, whether it puts too much refrigerant into the evaporator or not enough, depending on the line temperatures, and then maybe it wouldn't boil off and you could have flood back coming back to your compressor, different things like that, okay? So it's so important to understand what happens. Now, in this situation, I basically just took a shortcut so I didn't have to do an evacuation on Saturday because I knew it was going to be a disaster, but there was barely any vapor refrigerant left in the system, and I made a judgment call to go ahead and dump 19 pounds of refrigerant on top of that. I don't even think there was a pound in there, but there was just enough that it didn't pull any moisture or air into the system. So I think I'm going to be just fine. Now, it'd be one thing if you walked up to a 20-pound system and there was 5 pounds of refrigerant. It's questionable whether or not it would be a problem with a refrigerant like R404A. The glide is so small, meaning that the difference in boiling temperatures of the different components in that refrigerant that make up that whole refrigerant, I really still don't think you'd have a huge ordeal. But when you come to some of these new retrofit refrigerants that replace R22, 410A, those things are multi-component refrigerants, and you theoretically run the risk of fractionating that refrigerant when you top it off. Again, lean on the manufacturer of the refrigerant. Like, there's 448A is a new replacement refrigerant for multiple refrigerants, right? It's a new one that's kind of popular right now. It is a 400 series refrigerant, so it's also being phased out too, but regardless, that's a whole nother conversation for another day. The manufacturer, Honeywell, 448A, says that they really don't see any issues topping off the charge with 448A. So, lean on the manufacturer of the refrigerant, listen to their recommendations because they're the ones that are going to know their refrigerant the best, okay? Now, Saturday morning repairs, I mean, sometimes you don't want to spend days and days and days there. Now, I did find a couple things in this video, right? I also found that electrical issue. Now, if you look back to the very beginning clip coming into this video right here, you'll actually see that burnt wire existed here too, but I didn't catch it the first day. Because I was in tunnel vision mode, and it's probably not a good thing. I should have caught it the first day because theoretically it could have caused damage to everything else. If you have a loose electrical connection like that, and I believe that's what caused that, it can cause catastrophic damage to the system. It can cause low voltage, which can cause issues to the compressors. You can start to burn motors out. You can cause issues. That would have single phased all the compressors. Now, luckily, I don't think it was happening yet. I think it was right at the verge of it starting to cause problems, and it hadn't caused any yet. But you can clearly see how it burnt the insulation off of all that wire. So we as technicians need to be careful. And remember, I say this all the time, don't wear headphones, when you're on these job sites, so that way you can hear. Use your senses. Your senses are what make you a human, right? You have all these different senses, and, we can feel, we can smell, we can touch, we can hear. And it's so important to use those when we're being service technicians, so that way we can find problems. Now, luckily, the second day that I was here, I was able to find that burnt electrical wire and notice it before it became a problem, right? Nobody's perfect. Nobody will ever be perfect. The best thing that I see that we can do as technicians is try to be perfect. That's the best thing. We're always trying to be perfect, always trying to be the best technicians, understanding that we are human too. Okay. I left a clip in the video too about how my van was a disaster. It had been a long week. I had a lot of stuff going on. Work was busy. I had a lot of personal stuff going on, and it was just a rough week for me. So, You know, life happens. And I'm sure, just like me, it happens to every one of you at some point in time, you know, and it's normal for us to run into things. But remember, you know, to try to stay focused and try to stay in the game as much as you can. All right. I really appreciate you guys. You guys are amazing. All the support that I'm given from all of you is so humbling and so awesome. And I'm so thankful for that. Thank you so very much. I really appreciate you. Check out my website, hvacrvideos.com. We've got merchandise available there. It's a great way to help support the channel. There's a couple other different methods that you can help to support the channel. There's ways that you can monetarily or financially support the channel through PayPal, Patreon, YouTube channel memberships. There's links in the show notes of this video. Also, I have an offer code through True Tech Tools. Big picture, one word. You'll get an 8% discount on checkout. Helps to support the channel. I get a small commission when you do that. So any help is amazing. The easiest way that you guys can support the channel is literally watch the videos from beginning to end without skipping through anything. And that's the easiest way. It doesn't cost you a single thing. So thank you so very much. We will catch you on the next one, okay?